Alright, good morning. Today we're going to be talking about Math 111, in particular Chapter 4 begins a new chapter called Inequalities. Now, as I'm sure you know, solving inequalities is much like the process we solve inequalities with, with really one major difference. For example, if I asked us to solve and graph the solution set of this inequality statement, let's start out easy. 6x minus 27 is less than 9. Alright? Regarding manipulating inequalities, let me make some notes here. When you add or subtract an inequality through by anything, positive or negative, you leave the inequality arrow alone. When you multiply or divide an inequality through by a positive quantity, you leave the arrow. It's only when you multiply or divide an inequality through by a negative quantity, then you reverse the arrow. Alright, so please be aware of that. When you add or subtract, doesn't matter what by, you leave the arrow alone. When you multiply or divide by a positive, you leave the arrow alone. It's when you multiply or divide by a negative that we reverse the arrow. Alright, so remember those guidelines and we'll trudge through and solve some of these. I see 6x minus 27 is less than 9. Well, here I will add 27 to both sides and I leave the inequality arrow alone. I'll get 6x less than 36. Now I'll divide both sides by positive 6. And please note, I will accentuate that by putting a plus 6 in that denominator. The 6's cancel out on the left. I get x is less than 6. So once I've isolated a variable on one side of the inequality statement, and I've got a number on the other side, I call this my solution set. Now please notice, this is going to be an infinitely many number of values in my solution set. When we were solving equalities, we only had one solution. Here I've got infinitely many solutions. Less than 6 means left of 6 on the number line. So I'll draw an open circle at 6 and shade in everything left of positive 6. I usually put 0 as a milestone here, make sure I'm on the correct side of 0. And notice, our author has this notation for open sets with a parentheses like so for the graph. Okay? Alright, let's do another example here. Let me label this graph. And of course a box, the solution set, and the graph. Alright, let's try something a little harder. Solve and graph solution set. 2x minus 9 minus 10x is greater than or equal to 3 plus 4x plus 12. Let's try this one. Alright, I would encourage us to crunch together like terms on either side before we start crossing over the inequality symbol. I can combine 2x and minus 10x and get minus 8x. On the right, I get, 3 plus 12 is 15 plus 4x. Alright, now again I'm going to subtract 4x from both sides. I'm going to isolate my x variable on the right. Alright, if I do that, I would probably then add 9 to both sides. And I'll get a minus 12x on the left is greater than or equal to 24 on the right. Alright, now I've done nothing to reverse the arrow yet, but here I'm going to divide both sides by a negative 12 in order to isolate x on one side of the inequality statement. And here we go. When you multiply or divide by a negative, an inequality statement, that is when you reverse the inequality arrow. Alright, so this will be my statement here. The minus 12s cancel out. I get x is less than or equal to 24 over minus 12 is minus 2. So once I reduce it to the simplest possible statement, I call this a solution set. X less than or equal to minus 2. Well, as we saw in the last example, less than means left of. Minus 2 is somewhere left of 0. Less than or equal to, I'll indicate with a closed dot and shade in everything to the left off to negative infinity. Right, notice the boundary value here of negative 2 is included. Most students would indicate that with a closed dot here. Our author likes to indicate this situation with a closed bracket, indicating closure on the edge of that set. Alright. Let's try something a little more difficult. Solve. And graph. Solution set. Minus 7 is less than 16/15 times x plus 1. Alright, I'm going to take an attack, much like I would with an equation. I see fractional coefficients. No, I don't want to deal with these fractions, so I'm going to multiply both sides by positive 15. And when you multiply or divide by a positive quantity, you leave the arrow alone. So notice I have not changed the arrow direction. Alright, on the left-hand side, minus 15, let's see, negative 7 times 15. I'm reaching for my calculator. 15 times minus 7 gives me negative 105. Is less than. Well, now I have to apply my distributive law. 15 times 16/15 x is 16x, plus 15 times 1 is 15. Looks much better already, doesn't it? Alright. Here I would probably subtract 15 from both sides. Here my x variable is now going to be isolated on the right. So I'll get negative 115, negative 105 minus 15 is 120, of course. Negative 120. Let me clean this up. Negative 120 on the left is less than 16x. Alright, I will now divide both sides by positive 16. 16's, of course, cancel on the right. So I get this statement, well, minus 120 divided by 16 minus 120 over 16 reduces to negative 15/2. Now here is my solution set. Now sometimes students have trouble reading these right to left. This tells me x is greater than minus 15/2. If minus 15/2 is less than x, that means x is greater than minus 15/2. Everybody agree? Notice this inequality statement is kind of like a crescendo symbol in music. the smaller quantity, the arrow points to the smaller quantity, and the arrow opens up, if you will, to the larger quantity. So I claim this reads right to left as x is greater than minus 15 halves. Let me write it down. Alright, so here is my solution set. And if x is greater than minus 15 halves, well, negative 15 halves, I'll put that somewhere left of 0. And greater than means to the right of. So I'll draw an open circle at minus 15 halves and shade in everything to the right. All the way off to positive infinity. Alright, so here is my solution set, right here, and here is the graph of my solution set. Now we should be able to read these inequality statements both right to left and left to right. So beware of that. Some students have trouble reading these right to left. Let's try another example. Let's say 2/3 times x plus 2 is greater than 4/5 times x minus 3. And we want to solve and graph the solution set. Alright, how am I going to attack this first? Well, no, I'm not going to go through and multiply through these fractions here on left hand side and right hand side. I'm going to play it the smart way. I'm going to multiply both sides by positive 15. Why positive 15? Because positive 15 is the LCM of 5 and 3. I should be able to clear all the fractions away now. 3 goes in, cross cancels into 15 5 times. 5 times 2 is 10 times the remaining factor x plus 2, and I'll leave that there for a moment. On the right, multiplying through by positive 15. Again, when you multiply by a positive, you leave the arrow alone. 5 goes into 15 3 times. 3 times 4 is 12, and I'll have 12 times x minus 3. Alright, now I'm ready to multiply through. 10x plus 20 on the left is greater than 12x minus 3 on the right. Alright, I'm going to subtract 12x from both sides, leaving my x residue on the left. And if I'm going to do that, I would probably subtract 20 from both sides. I'll end up with a minus 2x on the left is greater than minus 23 on the right. Oops, I made a mistake. Did anybody catch it? Please forgive me. Let me go ahead and erase this. This should not be a 3 here. Let me write that out. And maybe it's good to illustrate this out. 12 times minus 3 is minus 36. So I'm going to correct that error. Check it again. 10x plus 20 on the left is greater than 12x minus 36 on the right. Looks good. Alright, let's pick it up again. I'll subtract 12x from both sides, and then I would subtract 20 from both sides. I'll get a minus 2x on the left is greater than, let's see, minus 56 on the right, right? Alright, now notice I'm going to divide through by a negative. Again, when you multiply or divide an inequality through by a negative, you must reverse the inequality arrow direction. So let me go ahead and write that explicitly. I'll take minus 2x, minus 56. I'm going to divide both sides by negative 2 and reverse the arrow direction. I'm going to kind of exaggerate that there. Well, minus 2x over minus 2 is just x. I get x is less than minus 56 over minus 2 is a 28, positive 28. Alright, so here is my solution set. X is less than 28, and as a graph of my solution set, I'll show all numbers on the number line. Less than 28 means left of 28. I'll put an open circle at positive 28, shade all values to the left, and again our author might use a open parentheses here to show an open set on the right edge. Alright, let's do a couple more here. We'll call it a day. Alright, I'm going to take a few from our homework list here. Solve and graph solution set. And here's our inequality statement. 4 is less than or equal to 9/10 x plus 1. Alright, there's a number of ways to go about this. I would probably subtract 1 from each piece. I'll get 3 is less than or equal to 9/10 x. Alright, once I subtract 1 from both sides, clearly I'm going to want to get rid of these fractions. I'm going to multiply both sides through by positive 10. Everybody agree? The 10s will cross cancel on the right, and I'll get 9x on the right is greater than 30 on the left. I would then divide both sides by positive 9. Well, 30 over 9, that reduces to 10/3, does it not? 10/3 is on the left, and 9x over 9 reduces to x. Alright, so here is my solution set. 10/3 is less than or equal to x. This is equivalent to x greater than or equal to 10/3. So again, you really need to be able to read these inequality statements left to right and right to left. Think of it this way. If I'm shorter than you, that means you're taller than me, right? So in any case, I will leave my solution set. You can circle either of these answers. They're both equivalent. They're both the same, right? So I'll now graph my solution set. X is greater than or equal to 10/3. Well, 10/3 is positive. Greater than 10/3 means to the right of 10/3. And notice equality is included here, so I'll draw a closed dot at 10/3, shading in everything to the right. And there is the graph of my solution set. Again, our author might use a square bracket to indicate closure on the left boundary. Either one is acceptable. I suppose most students would like to put in a closed dot, and that's fine. Let's try another one from the homework list. -3 is greater than 7/8 minus 1. Oops, sorry. Minus 7/8 x minus 1. And again, solve the inequality and graph the solution set. Alright, here I'm going to hold off multiplying by 8. I'm going to add 1 to each piece before I do anything else. Now, clearly I'm going to multiply both sides by positive 8. And when you multiply or divide an inequality through by a positive, you leave the arrow alone. On the left, positive 8 times -2 is -16, is greater than, on the right, the 8's cross cancel and I get 7x. So I get the statement now. Well, let's see, if I divide both sides by positive 7, again I leave the arrow alone. I'm dividing by a positive. I get 7x over 7 reduces to x, and minus 16/7 is on the left. Here is my solution set. Now again, if minus 16/7 is greater than x, that means x is less than minus 16/7. Please convince yourself this is equivalent to x less than minus 16/7. The arrow always points to the smaller quantity. Okay? Alright, so less than minus 16/7, well, minus 16/7 is of course negative, so it's going to be left of 0. And less than minus 16/7 means left of minus 16/7. I'll draw an open circle at minus 16/7 and shade in everything to the left. And there is the graph of my solution set. X less than minus 16/7. Alright, let's try another one from the homework list. Again, solve and graph solution set. I get 6 minus x divided by minus 2 is greater than or equal to minus 6. Alright, I want to isolate x on one side of the inequality statement, and I do that by doing algebra things to both sides of the inequality statement. Here, I see a denominator of minus 2. The first thing I'm going to want to do is multiply both sides of this equation by minus 2. But when I do that, I must reverse the arrow. Right? Make a note of that. I'll put it in red here. When you multiply by both sides by a negative, you must reverse the inequality arrow. So let me make a big deal about that. I'll get this statement. Alright, minus 2 cross cancels on the left with minus 2, and I get 6 minus x in my numerator is less than or equal to, now minus 6 times minus 2 is positive 12. Clearly I'll subtract 6 from both sides. I get minus x is less than or equal to 6. Alright, now I'm going to have to multiply by a negative again to solve for x. So I'm going to multiply negative x by negative 1 and multiply 6 by negative 1, and I must reverse my inequality arrow. Okay? So I get a positive x on the left is greater than or equal to minus 6 on the right. Alright, there is my solution set. And here is my graph. I want greater than or equal to minus 6. That means close circle. Minus 6 is included in this solution set. Shade in everything to the right. And there's my graph. Okay. Solution set and graph. Okay? Oh, we're having so much fun here. I don't want to stop. Let's do another one. Solve and graph solution set for the following inequality statement. 1/2 x plus 6 is greater than or equal to 4 plus 2x. Alright, clearly I'm going to want to multiply through by 2, but I'm going to hold off on that until I subtract 4 from each piece. of this inequality statement, 1/2 x plus 2 is then greater than or equal to 2x. Alright, I think I've crunched up together as much as I can. I'm going to multiply both sides of this inequality by positive 2. Again, when you multiply by positive, you leave the arrow alone. Well, I got to apply my distributive law on the left. 2 times 1/2 x is x, plus 2 times 2 is 4, is greater than or equal to 4x, so that looks good. Well, I suppose at this point I could subtract 4x from both sides. That will leave me with an x residue on my left with a negative coefficient. Or I could subtract x from both sides. Well, my x variable will be positive on the right. It will have a positive coefficient, but it will be on the right. And some students have trouble reading these statements left or right to left. All right, I suppose the choice is yours ultimately. Should be comfortable with doing it both ways. I'm going to subtract 4x from both sides. And if I do that, I would probably subtract 4 from both sides. And again, when you add or subtract anything from an inequality statement, both sides, you leave the arrow alone. No reverse needed. All right, on the left, I'll end up with a minus 3x. On the right, I have a negative 4. And clearly now I'm going to want to divide by negative 3. But when I divide by a negative, you must reverse the inequality arrow. So to divide both sides by negative 3, reversing the arrow, I end up with a positive x on the left is less than or equal to, well, negative 4 over negative 3 reduces to positive 4/3. So there's my solution set. X less than or equal to 4/3. I'll draw a graph of my solution set. 4/3 is positive. Less than means left of. Or equal to means closed dot. Shading everything to the left of positive 4/3. And we're done. And again, our author would probably indicate that with that closure on the edge with a square bracket. The solution set is here. And of course, the graph is here. Okay. All right, let's see. We got 3 minutes left till a half hour. Let me see if I can dig up another one here. That looks a little bit different, something we haven't done yet. I think we may have covered it all. I'm looking at number 70 in the text. Let me get a fresh screen here. Again, solve and graph. Solution set. 1/4 x minus 1/3 is less than or equal to x plus 2. All right. What shall I do here? I think the best thing to do in this particular problem is get rid of these fractions. Why deal with them if you don't have to? If I apply my distributive law correctly and multiply both sides by positive 12, I should get rid of all these fractions, at least for now. Excuse me. Again, when you multiply or divide by a positive, you leave the arrow alone. All right, 12 times 1/4 x. Well, 4 cross cancels into 12 3 times, and 3 times 1x is 3x. Minus 12 times 1/3 is, of course, a 4. Is less than or equal to 12 times x is 12x, plus 12 times 2 is 24. Beautiful. All the fractions are gone. All right. To solve this one, let's try something a little different. I'm going to subtract 3x from both sides. That will give me a positive x coefficient, but on the right-hand side. And if I subtract 3x from both sides, I will probably want to subtract 24 from both sides. And again, when you add or subtract anything from both sides of an inequality, you leave the arrow alone. I'll get minus 28 on the left is less than or equal to, well, 12 minus 3 is 9x, is it not? All right. Now I'm going to divide both sides by a positive 9. And if you divide by a positive, you leave the arrow alone. All right. I'll get an x on the right and minus 28 ninths that does not reduce. Right, 9 is 3 times 3 and 28 is 7 times 4. No common factors. I've reduced it as much as I can. So there is our solution set. Alright, now again this reads x is greater than minus 28 ninths. If minus 28 ninths is less than x, that means x is greater than minus 28 ninths. Again, the arrow always points to the smaller quantity. That means x is bigger than minus 28 ninths. Let me write that out equivalently. X is greater than or equal to minus 28 ninths. Here's minus 28 ninths on the left of 0. I'm going to recognize equality is included in the solution set. Close circle. Greater than means to the right of. Shade in everything to the right. And there is my graph of solution set. Alright, we're at the 32-minute point, so we'll call it a day. This concludes section 4.1, Solving Inequalities.